So, hello everybody. My name is Marlena Fork. I will be the moderator today of the last session of today. I'm very welcoming you to the first day of the conference. New experience for all of us. In this session, we will deal with the green vehicles, batteries. Sorry?
We can hear you.
Perfect. In this session, we will deal with the green vehicles, batteries integration into the vehicles. Julia will give a short introduction from the Commission side on this session. In general, it's split into 4 projects. We will see a video, one after each other, which will be 10 minutes. On the right side, you can see the conversation button, and please post here in the chat your questions you have to the certain presentation, and please turn off your video and your microphone during the video post. And please also do not click on the presentation, as the program here has problems dealing with that. After the videos, there will be 10 minutes of discussion for each of the projects. Yes, and I would like to give over the word to Julia now.
Thank you so much, Marlena, for this kind introduction. So indeed, if we look at the batteries framework and battery policy and how did we arrive to funding the projects we are going to hear about today, well, I can say that I could divide it in 3 major time blocks. So prehistory, meaning that electromobility funding and some of battery developments was initiated by FP7 already, especially in green vehicles and also in nanomaterials part. Back then, I've heard from colleagues that it was a challenge actually to persuade that electromobility will happen and that we have to put our stakes on this kind of the technology. But as we see now, that was the right choice to make, and that was the right cause to fight for. So time goes fast, and in 2017, so 3 years ago, so to say middle ages in our time blocks, we launched the European Battery Alliance, which harmonized all battery topics in Horizon Europe into one call. And it's this way we emphasize the strategic, competitive, social, and environmental importance of the batteries. The 2 projects presented today have started then and already finished. So the results presented today set the new normal and the new state of the art and the basis for the future. And talking about future, we are now at the forefront, the modern era, where batteries have evolved to be important, if not the most important of research innovation areas in Horizon Europe. The success of the new Green Deal, which is the core of the European policy work in the future, depends really on the green and sustainable storage of energy, both for electromobility and the stationary energy sector. Thus, for the future, we have established the European Batteries Partnerships, which will further work on batteries in the most strategic and oriented way, so that we are sure that every cent, we maximize the impact of this every cent invested in research innovation in Europe. And again, we don't develop batteries just for sake of developing them. We look at them for the performance characteristics to enable the electromobility and to make it very attractive to the customer. So in conclusion, this rapid political importance puts a lot of pressure on you, all battery stakeholders following today's session and also projects presenting today, to deliver these very ambitious political targets. But I'm sure we can do it, taking 1 or 2 steps at a time. And I'm very much looking forward to hear the results of the project finished and those still ongoing today. Let's enjoy the session. Marlena, back to you.
Yes, thank you very much, Julia, for your nice words. I think we will directly go into the first presentation, which will be Spider, where we talk about safe and predated high energy density batteries based on sulfur, rock salt, and silicon chemistries. And I'm very happy to hand over the video, or to give a speech to the video of Cedric Juan. Sorry. Thank you very much for the presentation. Now, as we heard all of the contributions from the different projects, I would like to ask the speakers to turn on their camera and their microphone, so that we could go directly into the questions and answers part. And I would suppose that we will start with the first project presented, which is Spider. And as we have left 26 minutes, I would suppose for every project have around 6 minutes of discussion. So please feel free to state some questions to the Spider project.
I believe there were a couple of questions in the chat. Maybe you handle those first.
So let's go through the chat. So there was the question, who is doing the prelidation? But I think this was already answered, that this is done by TU Munich. I would have a question. I mean, you are handling here with metallic lithium, right? With metallic lithium foils, sheets, and so on. How do you process this with a roll-to-roll process?
Yeah, so for now, the process the roll-to-roll process is designed but not yet implemented. So the first generation of lithium-ion cells using lithium metal will be done by hand. It means that we will place some pieces of lithium metal by hand within the cell. And we hope that for the next generation, middle of 2021, we will have the roll-to-roll process where there is a carrier foil in order to bring the lithium metal and in order to handle it.
Okay, very interesting. I think also this roll-to-roll method is also interesting for all the technologies, not just for prelidation, but also for...
Yeah, I see what you mean. You mean for cells with lithium metal?
Exactly.
Yes, so I think it will depend, because for now the lithium metal can be used for Gen 4B. It means solid state batteries using lithium metal.
Yes.
But so far, from my understanding, I think that we don't have yet industrial process to prepare solid state batteries, and I'm not sure it will be kind of roll-to-roll process. So I don't know, but we think that prediction can be very useful for different lithium-ion chemistries, and even also for specific cathode developed in the past without lithium. It can be used, so it can be an interesting progress for lithium-ion cells using liquid electrolyte.
Okay. There was also a question from the fading of the positive. Is it that the fading coming from the positive or the negative electrode? As you say, you have a capacity fade or capacity loss of about 30%, right?
Yes, yes. One of the challenge for high energy density is to use high capacity materials. For example, here it's at the anode we have silicon composites with a quite high capacity, for now around 700 milliampere per gram, and we know that there is a difficulty to maintain the capacity upon cycling. So we know also, because we did a benchmark at the beginning of the project, that in this case the capacity fading comes from the negative electrode, so the silicon, and it's also a reason why we try to implement preheating, because it's also a way to improve the cycle life.
Okay. Is there any other question coming from the audience? Maybe. Then maybe I will have an additional question. So you said you have a silicon carbon composite on the anode side. What is the percentage of silicon and carbon in this electrode?
For now, it's around 12%. We target 700 milliampere per gram for the capacity of the anode. You have to compare with 350 for graphite, for example.
Okay, okay. Yeah, this would be a big increase indeed.
Yes, 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 but yeah, it's the increase you need if you want to increase for at least a few percent the energy density.
Okay. So I would say, if there are no further questions from the audience, are there any?
So sorry for the mask, but I'm in my office and it's mandatory.
Of course, no problem. No problem on that. So maybe I have one additional question here. So for the preheating, that you make this preheating based on contact between the lithium and the negative electrode, right?
Yes, yes. In this case, by using lithium metal. But in the project, we try also to develop other preheating methods. For example, sacrificial salts. It's compounds containing lithium, and there is a decomposition of the salt at the first charge, and the decomposition delivers lithium ions. It's
Okay.
another way to do it.
And is this done via a wet route, so mixing these components and then drying them, or is it without any liquids involved?
No, no. In this case, the salts are combined, are integrated in the cathode. It
Okay.
means in the positive electrode,
Okay.
and it's a powder which is mixed with other components of the positive electrode.
Okay. So it's a dry method, right? More or less.
Yes, yes, but after it's a wet process to make the electrode.
Okay. Okay. So if there are no further questions on the Spider Pro project, I would like to go further to the iModBet project. Are there any questions coming from the audience? Don't be shy. You can state some questions here if you want to. Good. If there are no questions coming from the audience, I will go through the question through the chat question. So there was a question regarding on the further thermal or the insights, further insights into the thermal management of the pack. Was this already answered? I have to look. I think not. So how does it look with the thermal management of the pack? Can you give us some more details on that, please?
Yeah, thank you for the question. I have answered the question in the chat.
Sorry.
But
Okay.
nevertheless, I mean, maybe after my explanation, there could be more questions. No, don't worry. So basically, as it was explained in the video, we have two types of thermal systems. One is air-cooled by Renault, and the other one is a passive system. The air-cooled system actually in iModel, we did not focus on anything related with the thermal management. I mean, the software or the logic control, we are using the same that is used by Renault. The innovation in our case, it is to the hardware or the air ducts that we have designed inside the battery pack to guide this air through the heat fins and pipes and the rest of the battery pack that we have designed in order to make a very modular design. So the innovation is in the hardware. There is nothing we are not using from the series thermal management system. Maybe the threshold values when changing from, for example, when the chiller is on or when the fans are on, are modified, because this is also something easy to modify by the energy control unit of Renault. But they wanted to focus on the improvement of the hardware itself rather than in the software.
Okay. There was also a question regarding the automotive requirements on rigidity. So how do you deal with that when you have this modular built up?
Indeed, this is one of the biggest challenges, because, as I said in one of my last slides, modularity has some advantages, but also some disadvantages. Okay, so in terms of mechanical stiffness of the product, modularity has several disadvantages. And even if we were successful by doing some acceleration and shock simulations on the CAD files, let's say, when we first built the modules, we already faced some problems during some vibration tests according to the UN 38.3 standard, which is one. I mean, this is the basic one for shipment, and then there are additional ones for automotive application, as the Air 100. And indeed, we know how to fix it, or in some other words, we know which is the source of the weakness. One of the problems is that some of the parts we are building are 3D printed, so the tolerances are not so good as the ones that you will get when you are entering into mass production with injection molding, for example. And additionally, it is fundamental having a physical device as soon as possible in order to improve any deviation that we have found late. Okay, so due to these constraints in such a project, the final product, as I said, would need, I would say, basically because of these mechanical weaknesses, an additional 1 year review of the battery pack design we did, in order to be able to fulfill not only the mechanical but all the high demanding requirements of automotive application. We know where are the problems, we know how to solve them, but as I said, in order to have a really industrial prototype to be tested to fulfill the requirements, this should be done.
Okay, thank you very much for this detailed answer. There was also the question raised with the weight of the module, and as far as I can see, this is not that easy to answer, and you do not want to share some inaccurate data, right?
Yeah, basically, I mean, I have been checking the bill of materials. I have been checking, but the problem is that we are not discussing these topics together with the battery pack assembly issues that we have faced, and at the moment it's in standby. there is a very challenging objective of 20% reduction with respect to the original battery pack. That I must say that will be hard to fulfill. One of the reasons, again, as I said in my last slide, is because of we know that there are a lot of redundancies in some of the materials that we have used. For example, in order to guide the air through the heat fins that we have assembled in the modules, some of these parts could be removed. Some of these parts could be part of the battery cap itself, and this way the weight could be even more reduced. But of course, this comes after checking a physical prototype, which is something that we are doing now. The problem is that once that you are checking this and realizing which are the points in which the improvements could be done, you need to redesign, remanufacture, assemble everything, and this will be done after the end of the project.
Okay, thank you very much for your detailed explanation. I think if there are no questions coming from the audience, no, obviously not. Then we will go further to the next project, which is Everlasting. So are there any questions coming from the audience? So if this is not the case, I would like to go through the question and answer list, to the question and answer chat. So there was the question regarding the BMS workshop, as far as I see. So you said you made a workshop for standardization, and if this is more or less a call for participation to take part.
Yeah. Do I have sound? Can you hear me now?
I can hear you, yes.
Yeah? Oh, okay, then it's improved. In the beginning, I didn't have sound. Okay, very good. Maybe to answer about the workshop on the BMS standardization. In fact, it's a quite process to go to standards. And as I said, the information we collect is input for pre-normative standardization. Standardization looking at how do you design a BMS system, looking at the hardware, software, or interfaces, which are maybe specifications which could be useful for the whole community to share them, because if we standardize parts, maybe costs can be lower. But also, as I said, yes, BMS is a critical thing. It's a differentiator sometimes on the market, having a battery with a good BMS. Yeah, you don't want to share all your details. For the workshop we did, it was on an invitation basis, in the sense that we didn't want to have a too big group, because we really discussed proposals that we had put on paper. We wanted to have people from different parts of the value chain. And in fact, in these workshops, we even didn't look only at passenger cars, but we also had people from electric motorcycles, boats. So we had a quite broad scope of batteries in mind. But it was not the idea to have a closed group at that sense. So the documents are available on the website. We can discuss with it. We are in contact with some technical committees at Sensenelec. One of our advisory board members is very involved at DIN in Germany in standardization. But we saw that standardization efforts were taking time, and these talks are not going that quick. For the design of the BMS. On the other hand, for BMS testing, our partner TÜV Süd did a lot of work. And even there is also a lot of progress to be made. How do you test BMS as standalone systems? Which functionalities do you want to test? And at that part, it's even more important to have an agreed protocol or standards to be able to compare functionalities, because it's always benchmarking things on the market is not always that easy. If everybody is using their own way to measure things. So we make progress. It was not the main topic of Everlasting. We want to develop features and improve the BMS system as such, but where we could standardize things or make suggestions, we try to do it. So it's an ongoing thing.
I mean, I would have a question on that, as there is no additional question in the chat. How long does it take you to do, for example, cell testing or testing of a system to get enough information for calibration of the BMS?
Yeah.
Can you make here an rough type estimation? As I know, I mean, you always have this issue also in our company. This is nothing that easy to get a good or to get an, how should I say, an effective testing time here.
Yeah. It depends a bit on which type of test you want to do or for which purpose. We did in Everlasting, we did destructive testing. We did nail penetration, crush tests to check thermal runaway effects. These are, of course, short tests. That's a test you do the test, you measure things. Our aging tests, I think we have tests running now for 3 years, so some tests. So we have calendar life testing at different state of charge, put these on the shelf and at different temperatures. These are very long tests. On the other hand, we have cycle tests, aging tests, putting a drive cycle on it. For that, we used real life information from our partners. They gave us a typical drive cycle from their vehicle. And of course, you try to select the worst parts out of it, which damage or age your cell probably quicker to shorten the test of the time of the test. That's why we also want to share these data sets because it's such a time-consuming thing, and there are so many cells to be tested coming on the market that part of these things will be shared. If people are interested in these results, we can definitely share them.
One last question from my side. If you have, for example, calibrated a BMS and there is, from a vehicle point of view, an update in the cell, successing cell of the current cell, do you have to make all the BMS testing again or just certain tests? So, for example, if you improve the cell chemistry or such kind of things.
Yeah, it depends on which feature we're talking about. Some can be reused as it is, and for others you have to do sometimes a kind of new some reference tests again. But a lot of things that we developed on the models, we did a model-based BMS system. So a lot of models are running on top of the BMS. And these models are sometimes a little bit chemistry dependent and sometimes can be reused as is.
Okay. So. Okay. Then thank you very much for your for your answers. And let's go to the last project, which is Selfie. Are there any questions coming from the audience?
I think I answered all of them in the chat.
Okay, maybe just go through them quickly so that all the other participants also have the information on that. So maybe you could just help me.
But it was mostly related to the thermal simulation and the thermal management. So the first question, if I remember, was the software we use for the thermal modeling of the vehicle, so the cabin and the battery. So we use for 3D modeling Star CCM Plus, and already someone from Siemens in the chat. So Siemens is developing this software. Already contacted us to check if this is the correct software. We need help with this, so it's very nice. And for the 1D or 0D simulation, we use also a software from Siemens, which is called SimCenter AmSim software. So this was the first question, if I remember correctly.
Yeah, there was also some. I think the first question was relating the selection of the cell. If I'm exactly.
For the thermal, for the preheating, and so as I answered, the goal of the topic is really to handle safely the fast charging application, so up to 140 kilowatts. But also the preheating is also one of our aspects as well in the control strategy. It's not our main focus, but it will be tackled also in the control strategy of the system.
Exactly. So if the system is not capable of fast charging, it doesn't make sense to.
Yeah, but we choose good, were very excellent cells for that. So we know that we can handle the fast charging phase.
Exactly. So on cell level, the 140 kilowatts, what is this on cell level? What kind of charging C rate? Do you know that?
It's 5C.
It's 5C.
5C, but the cells can go up to 8C. So it's 8C, it's 183 amps. And so 5C is 125, something like that. Amps.
I'm just checking again the chat. I think you answered every question. Maybe I have one in the background. So you talked about the PCM materials, right?
Yes.
PCM materials, where are they located? In between the cells, at the corner of the
cell? So you have, no, there are both plates located on between each row, so on the bottom of the cells. So we have 2 layers of cells, and in between these 2 layers we have the PCM plate. So that's really the PCM for absorbing the heat, and also the housing is made of PCM as well.
Okay.
The housing, so the casing of the battery pack is also made of PCM.
Okay. And did you also test already the fast charging? So how many cycles can you do with this kilowatt you want to apply?
At pack level or cell level?
Sorry?
At which level? Pack? Battery pack? The assembly... we haven't started the assembly yet, so we don't know how many cycles. But at cell level, we can do more than 5,000, 6,000 cycles. So.
Okay, very impressive. Yes, very good. Okay, are there any additional questions coming from the audience? If this is not the case, I would like to thank everybody who has joined this session. It was a pleasure for me to host or to moderate this session. After this session, I would invite you to go back to the lobby and join the online exhibition, or you can also go back to the lobby and join the Zoom meeting, which will summarize the results of the sessions which have been in parallel to this session. Thank you again. It was a pleasure. Thank you also to the great contributions of the partners here and to the speakers. I wish you a nice remaining evening and see you soon, hopefully face to face. Thank you.
Thank you. Bye.
Bye.
See you.
Bye.
Bye-bye.
Thank you. Bye-bye.